All right, the first two say, is the relationship between the values in each table in inverse variation? If so, write an equation to model it. Remember, for these ones, you are looking at your x and y values, and you're multiplying them together. So I'm going to do 2 times 10, that equals 20. 4 times 5 would equal 20. 5 times 4 would equal 20. And 20 times 1 would equal 20. If they're all the same numbers, so if I'm done and all of these numbers down here match, then my equation is an inverse variation. So this one's going to be yes, it's an inverse variation. And then we have to write an equation. Now remember we had this like equation that said k equals xy. Well, we just multiplied xy, so we know that k has to equal 20. So we have 20 equals xy. Now you could leave it like that. I think more traditionally your equations are something like y equals k over x. So if we do that, we'd have y equals 20 over x. And that would be your equation. Let's look at the second one. Again, we're going to follow the same steps. You're going to multiply your x and your y, and you want to get the same number when you multiply them. So for the first one, we're going to do 1 times 610. That would give me 610. We're going to do 24 times 12 for the second one. And when I do that, I get 288. Now, right off the bat, I only did 2, but my two numbers down here aren't equal. So that tells me that's not going to be an inverse variation. And if it's not an inverse variation, then you don't have to write your equation. So that's that. All you have to do is multiply x and y, see if they're equal, and then set up your equation.